Hi, we're at the Quinte Mall for the Quinte Regional Science and Technology Fair. I'm Liz Ingram, and with me is Chris Spencer, who's been with this for I don't know how many years. What school are you with?
I'm with Harry J. Clark Public School.
Yes, and you've got kids running all over the place and getting their projects ready as well.
Yeah, I have 12 entries from our school are here, and as well my own daughter and son both have their own entries as well. So.
Of course.
Of course.
You didn't badger them.
I push them as hard as I push anybody else.
And you've got a number of helpers from your school helping out today as well.
Yeah, I have 3 students have come along to help with crowd control. They've willingly volunteered their time today.
I bet they did, yes.
Of course, with the proviso that we feed them donuts and pizza. But yeah, and then I expect at some point we'll even manage to get a picture of them.
Now, I didn't realize the science fair started years ago at Moira Secondary School. I always thought it was at the Armories.
Well, it initially started at Moira Secondary School, then it moved to the Armories a number of years. The fair at this point is a 41-year institution, and it's so it's been housed in several venues.
What year does 1960 something?
41 years ago. But yeah.
Oh yes. 41 from 2001. So that started at Moira Secondary School and then moved to the Armories and then finally to the Quinte Mall.
Yes, moving to the mall has been a really good an asset to the fair. It's really increased the public awareness. It puts the projects out where they should be for the public to see, because many of them have information that relates directly to the public.
What amazes me is following the students year after year, you see them go up through the grades, through high school, and some of them go on to university and become involved in science or the medical field.
Certainly, this is really a breeding ground for our technicians, for our scientists, and our doctors. Kids who go on to Canada-wide come back really excited about the experience, and they're scouted there for opportunities by institutions. So it's really a good place to hone your skills for those kinds of fields.
In fact, 2 brothers, the Grant brothers, they've come back to judge, and they've gone on to university. I think one's graduated now, possibly.
Yeah, David and James Grant were perennial entries at the Quinte Regional Science Fair. They entered every year that they were in high school, and they had a great deal of success. James, I think, went to 6 Canada-wide science fairs, probably the most any student's gone.
Okay, well, now the judges, where have you got them from?
Judges are from all parts of the community. We have doctors, engineers, teachers, lots of teachers, people from Loyalist, and technicians. So there's retired people as well as people who are currently working.
I think I saw Doug Old from Loyalist College, the president.
Yes, we have certainly Loyalist supplies. Both some of their professors are here, and many of their students are here as judges too.
Okay, now what do we expect to see today? We've got, what's the youngest age group?
The youngest age group are the children in grade 4, so they're about 9, 10. Excuse me, and then we go right up, of course, to OAC. For the younger students from grade 4 to 6, their top award is some very nice CorelDRAW software for top in class. For the grade 7 to OAC, the top awards will be the Canada-wide trip.
Okay, well, maybe we could carry on and pick some of this conversation up later and see some of the students.
Certainly, we've got a very classy group of projects to look at today, so I hope we manage to catch some of those kids on tape.
Okay, thanks, Chris. So we have 2 grade 4 students from Maynooth Public School, and your name is?
Jessica Davis.
How old are you?
I am 10 years old.
And?
Megan Scott.
How old are you?
9 years old.
You had to think about that one. Okay, now the project that you chose is what?
Seashells.
And what about seashells?
Well, they're really cool. And, well, they're kind of like a rock, but they're actually homes to living creatures.
Oh, but what's your hypothesis? What are you trying to prove?
We're trying to prove that seashells live all over the world, and there's more seashells than people in the world, and that's a lot.
I'll say. And I see you got a notice up here that says, can you really hear the ocean in the seashells? I always thought I could I?
No, you can't really, because it's the air moving in the seashell, and it's kind of saying to you, like, I want to get out. If I can't get out, then I'll break out, kind of thing.
So what kind of creatures live in seashells?
Mollusks.
Oh, and crabs? So, well, sometimes they do, don't they?
Well, it's
A
called,
hermit crab.
yeah.
Yeah. And snails live in them too, and lots of creatures live in them.
Sometimes when one creature abandons the shell, another one takes over, doesn't it?
Yeah, it's like a living life for it.
Okay, now can you show me some of the shells you've got? And when you show them, can you show it to the camera so they can see?
Sure. I'll do this.
These three right here are fossilized seashells. They're homes to different kinds of creatures, but mostly mollusks, because other creatures, there's hardly almost any other creature that lives in a shell.
What is a mollusk?
A mollusk is like sort of like a snail, but it's only soft, and it's like the skin, only it's really squishy and soft. It's kind of like flubber.
We have a picture of a mollusk, and Meg, where
Maybe you could show us then.
it's not very big, but
So let's see if we can pick it up here or not.
and this is a mollusk there. And I always thought that they looked like a snail. Everything that lived in a shell looks like a snail, but they don't. They're all different, like the hermit crab, and lots of the little crabs that live on the beach, and a lot more.
What made you choose this topic?
Well, we just thought that it'd be interesting, and it's different, and we had fun doing it.
And do you get to go to the seaside sometimes?
Yeah, at the beach mostly.
Which beach?
Papana.
Where's that?
Papana Lake. It's like a campsite where you get,
In Ontario.
yeah.
Do you ever get to the ocean?
No, my grandma Keller has been there though.
So where did these shells come from? Some of them came from the ocean, didn't they?
Florida mostly.
Oh, so you have been down there.
I went to Florida on my 8th birthday, and I went and I got a whole bunch of seashells, but most of them are attached onto the carrier seashell, which is...
Show us that one.
This is a carrier seashell. We didn't really have a real
Can you
one.
turn around and show that?
We didn't really have a real one, so we glued them on, but we still had fun doing it.
What's the bottom of that one? It looks like a pretty big one, doesn't it?
Yeah, these
Are
are...
you sure you can't hear the ocean in that one? That looks pretty big.
I know, you can hear the ocean in it, but it's not really the ocean, though. Yeah.
So the big shells, the little ones attach themselves to the big shells.
No, but the big one goes around with the other seashells. But usually when they're at the bottom, they're kind of like a magnet. They stick onto them and they make a thicker shell so that the seashell can be used. So that's how seashells get bigger and thicker.
Okay. Very good. That is a fun topic, and I see you've got a lot of pictures up here that you've accumulated and you've stuck up there, and there's is that a picture of a mollusk down? I'm not sure if we can get that on the camera there, but it's a...
That's not a mollusk. That's not a mollusk. It's a shell, kind of like this one here at the side.
Okay, thank you very much, both of you, and good luck on the results then. So you just judged.
Thank you very much.
Okay, we have 9-year-old Brittany Flindle from St. Mike's. And what grade are you in?
Grade 4.
And I see you had to put down your donut, didn't you?
Yes.
To come and talk to us. So you've chosen the topic, Invisible Ink, Another Use for Lemon Juice.
Yes.
Yeah. So what was your hypothesis?
The hypothesis was that I thought that the lemon juice was going to work for invisible ink, and I found out that it did not. My conclusion, it didn't work according as planned.
So what did you have to do to come to that conclusion?
Well, the first step I had to take was a lemon juice. The lemon, I squeezed out all the juice after I cut it in half, And then I took a Q-tip, I dipped it into the juice, and wrote with the lemon juice on a piece of paper a message.
What kind of a message?
Well, the message I wrote was test, because my mom wanted to keep it simple. And then I put it over a lamp for 4 to 5 minutes, and then I found out that it didn't work.
Oh. Well, what made you think it was going to work then?
Well, the sweetness, the sourness in the lemon, I thought that would burn up and make it brown because it's like burning. And so I tried that and it didn't work.
So you learned something.
Yeah.
So let me see some of the things you've got here to prove your point. You've got the lemons
Yeah.
and the Q-tips.
Yeah.
And then where was the paper you wrote on?
And this is the paper before I put the heat on. And then this is the paper after I put the heat on.
Oh, so this is...
Before I put the heat on and it's dry.
Okay, did you write on that one?
Yeah.
And then this one too?
Yeah.
Yeah. And no message came out. You can barely see something on there, but the camera won't pick that up.
No.
So you'd have to have infrared glasses or something to read that.
Yeah.
So what did you write? Oh, you wrote about the procedure and you did some diagrams.
Yeah.
So you did a lot of work.
Yeah.
Thank you very much. You really did well, and I think your explanation is very good. You may be a scientist someday.
Thank you.
Thank you, Brittany. Two grade 4 students from Foxborough Public School, and they've chosen a project called aerodynamics. But first I want to get your name and your age.
Nick Crowder, I'm 10 years old. Shannon Kirby, and I'm 10 years old too.
And who's your teacher?
Miss Smith. Miss Smith.
Yeah. So she allowed you to work together.
Yes.
Thousands wouldn't, but she did.
Yep.
Right. So why did you choose this project?
Because we wanted to do something with connects and cars, and we wanted it to be cool. So we had a ramp built, but we couldn't bring it. It was too big. So we just brought the cars and we set up a board.
Too bad they couldn't see it on the ramp. That would have been fun. Okay, so can you show us what you've done back here?
We've took 3 of our cars. A tall car.
Yeah, can you show it on the camera? We can't see it.
We took a tall car. A long car.
Hold it up so we can see it, yeah.
A long car. And a wide car. And we put them down our ramp that we had. And we thought that our wide car would go the farthest and the fastest, but then we had all these trials, and in our conclusion, the thin car and the long car went the farthest because of its skinny front end and its more aerodynamic shape.
So do you think you'll get into car building?
Yeah, probably.
Did you work with your dad around cars?
Yeah, sometimes.
So you really like, I don't know, you two getting involved with cars, right? Racing cars.
Yeah.
So where besides this, where did you get some other information? Did you look up in books?
We looked in some books and some in our library, see if we could get any ideas there.
And what made you come up with these sort of things? These are, what are they anyways?
Connects.
Oh. So how did you think? Did you have to measure how big you went?
We had to measure how long they were, how far they went, how tall they were, and a whole bunch of stuff like that.
Did you have to time it?
No, we didn't have to time it.
You just want to see how far they would go?
Yeah.
So how long did it take you to figure all this out?
About 2 weeks.
So you played with toys for 2 weeks?
Yep.
That's good. Did you do this in the classroom or at home?
In the classroom and at home, we did some work.
And of course, you have to write all this up. And what's this? Is this all done on the computer, the typing?
The typing, yeah, the letters for our title, we traced out, and we took some extra connects and put it on our board to make it look like a car.
So you haven't been judged yet, have you?
No, not yet.
You starting to giggle?
Yeah.
Don't do it when the judge comes around. What do you think the judge is going to ask you?
Like, what gave you the idea to do this, and how long did it take you to make your cars and stuff like that.
So you're anticipating his questions.
Yep.
And don't laugh when he comes around. Oh, I shouldn't do that to you. Thank you very much. It was interesting, and good luck. And I hope you have good luck with the judge, eh? And the explanation is really good.
Okay.
Okay, we've got James Lowry, a 10-year-old grade 5 student from Harry J. Clark.
Yes, Harry J. Clark.
Now, you've chosen to do a project in French. Are you French Canadian? No, you're not with an...
I'm French immersion, and when you're in grade 5 French immersion, you have to do your science fair project in French.
Okay, now the subject you chose, it's all written in French, so, oh, my French is not that good. What is it?
Well, the test, it's about words and symbols and which one's easier to recognize. Because I found in computer programs, you point and click on a symbol, but in the olden days, and not too old, because in the olden days there wasn't computers.
Yeah, just be careful on that, okay?
Okay. They used words, so I'm trying to find out which one's easier to recognize.
Okay, can you point out some things?
Well,
Okay, we're going to show the camera, remember? You can't put your back.
I tested with these sheets, and I asked the people to tell me what color the word or the symbol represents.
Okay, give me okay, open it up again and give me an example.
Well, for instance, the carrots, that would represent orange. Yes, and by the way, I use colors because it can be represented 3 ways on a piece of paper. The color itself, a word, or a symbol. So, anyway, I found that words were easier to recognize than symbols. I think they changed to symbols for using because it's more showy.
Okay, now the color, to be able to see, you couldn't see some of the colors there. It was harder to see some symbols or whatever was written on there than other colors.
Excuse me?
Okay, the colors that you chose, you put symbols or words or whatever. And depending on the background, it was harder to see.
Well, I did that too, because I also tried to find out if there's a message conflicting all the time, be changed. And it did. So like, I had a blue background and I had the word yellow. And it took longer for them to say the word yellow because their brain got mixed up.
Well, they were thinking of the word
Color, yeah.
Oh, interesting. So is this all in your question and your hypothesis and your conclusion?
This is mainly a sum up, if you could call it that.
My goodness, you've written a lot there, though.
Yeah, it was heck of a job typing.
Now, why did you choose that? What made you choose a topic like this?
Well, I found it was very interesting, and myself, I wanted to find out what the answer was.
No, but did you have any help from a teacher? Or?
Well, my teacher corrected my French, and she went over and she took 2 paragraphs and she said, "This isn't clear. Go write it again." So I went and wrote it again. And my mom helped me type, and my dad had to cut up all the piece of papers because he wouldn't let me because...
You got other people to work for you? How much did you pay them?
Zip. Well, he didn't let me cut it.
But I was thinking the subject that you chose was so different. I just wondered if somebody had come up with that topic or you had been...
I got the spark of an idea from a book. It said, write down words on a piece of paper that with a different color than what you wrote down and as people try to figure it out, there'll be confusion. But that's mainly all I found. The rest, it was sort of brains.
storming.
Okay, now have you been judged yet?
No, not yet, but they've safety checked me. They said it looks like I don't have a chance in getting anything but in biology thing, but it doesn't have to.
Good experience, and it's a lot. I mean, you've learned a lot, and now you have to present it in French to the judges.
I don't know that yet. So.
Well, I wish you all the best then, and good luck, and I hope you get something for this. Although you're not.
I don't know.
Yeah. Well, good luck, because this is a hard topic to choose, especially in French. And I was listening to you French earlier, and it was. I was amazed. How long have you been in the French immersion?
2 years. Yeah, it's a fun thing to go in, and my mom says it helps you get jobs.
It certainly does, and it also helps you to understand the English language a little bit better, because of the a lot of our language has come from French.
Yes, come like communique and communique and I forget.
Communication has come.
Communication, yeah.
Well done, and good luck.
Thank you.
Okay, we've got two more students, grade 5 students from Frankfurt Public School, and your name is?
Mike,
And how old are you?
10.
Your name?
Jake,
And how old?
11.
Okay, and you've chosen a really good topic called Clean That Water. And what made you choose that subject in the first place?
Well, we were first looking through a a science book on different projects, and it seemed the most interesting.
Plus, there's been a lot in the news about that lately, so it's really interesting.
Like Washington.
So, and then you two decided to work together on it?
Yes.
You have the same teacher?
Yep.
So, what was your hypothesis?
We thought the granular filter would clean the water the best because it's a natural way that a spring river gets cleaned.
What other things did you use to prove the hypothesis besides using the granular thing? What else did you use?
We also sort of looked at we tried the paper filter, that coffee.
Oh, the coffee filter?
Yeah, coffee filter, and fabric. I can't exactly remember where we got the fabric idea, but
you just thought you'd give it a try anyway.
Yeah. We still discovered that we were right. The granular did work the best.
So how long did it take you to put all this together?
3 weeks, I think.
And then did you work on it every day?
No, not every day.
He had to go between his mom's and dad's.
So they had to work at the school and at home and try to get together. Okay, can you just sort of back to one side and just show us what you've got here? Just on the far side, maybe if you can back up a little bit so the camera can get it.
Well, first, this is a paper filter. We made it out of, well, first, on every single last filter, we have paper towel because you couldn't really tell if the residue, you couldn't tell if the residue was actually on top of it, on top of the sand. So we put paper towel, and then we stuffed cotton balls in the very bottom instead of putting all the sand, because the dirt would probably fall through into the vase. And
so did you pour dirty water into it then? Is that what happened?
Yeah, we made it out of tap water and then mixed it with what's it called? Gardening soil.
And it all looks fairly clear to me. It looks fairly clear in all of them, isn't it? But one of them is better than the other.
Yeah, the granular filter, we noticed that it took the longest, but it did give us the most water, and it was the cleanest.
And that's the middle one, is that?
Yeah, it's the middle one.
Now, granular, what substances? Oh, I see. It's got a lot of
Of sand and rock.
So very good. So, and the last one was some sort of fabric.
We used towel, wool, and cotton, I think, wasn't it?
Oh, burnt this one?
Yeah, I'm just gonna check. Shredded cotton towel, shredded wool, and shredded cotton.
So now we know maybe if you're setting up a house at home, what you should do to get clean water in the house.
Probably well, if the water's contaminated, you could probably boil the water, and just to make sure, you can probably make one of those.
And I see you've done a lot of diagrams and, of course, computer related things. But now, have you been judged already?
Yes, once.
So you still have several more judging to go. Now, but you had to present this in front of the school first.
Yes.
Were you nervous?
Sort of.
I wasn't.
Not really. But I had to chase him down a bit.
I wasn't really that nervous because I knew everybody there.
Well, sometimes it's even more nerve-wracking getting out in front of people that you know than sometimes strangers.
Not to me.
Sort of in front.
Do you think you want to go into science in the future?
Probably, yeah.
Yeah.
Well, good luck to both of you, and hope the judging goes well for you.
Thank you. Thank you.
We have Jocelyn Barnett, a grade 5 student from Maydock Township.
Yep.
And what did you, let me see, optical illusions. And that, yes, that does look, oh, you have to adjust your eyes to that. So what is your hypothesis or question on this?
Well, I tried to see if adults or a child's brain reacted the same when they looked at an optical illusion. So, and then I went around my school asking teachers, like 11 teachers and 11 children, to see what they saw in this picture here and that picture there. But the outcome was like they both seen pretty much the exact same things.
Really?
Yeah. I was surprised by that. And my hypothesis was wrong. I thought that childs would see optical illusions better because they're more looking around and looking out and asking a whole bunch of questions, and adults know everything, so I thought that children would be able to see them better, but it turns out that actually adults and children see them both the exact same, pretty much.
Now, what age group did you use? When you say child, what age groups were they?
Grade 5 students, like 10 or 11.
What about you? You didn't try on younger children then?
No, I didn't.
Did you try on adults?
Yeah, I tried on teachers, actually.
But the trouble with teachers, they've seen some probably, and so it's probably harder to ask someone that's already seen it, you know. But anyways, it's still a good try. And so the conclusion was again?
The conclusion was that adults and children see pretty much the exact same thing when they look at an optical illusion, well, through the two pictures that I chose. So,
okay, I see two people's faces. But now, if I looked at it another way, we would see a vase.
Yeah, there's...
So what did they see first?
Well, different kind of things. Like, adults seen 8 adults seen faces, 9 children seen the faces, and 2 adults seen the faces, or the vase, and 2 children seen the vase, and 1 adult seen both.
Oh, okay.
Yep.
Okay. And then this one, well, there's, I guess, I bet you it's the men at the same height, but to me, it looks like this man is a lot taller than the other 2. Yeah. But actually, they're the same height, right?
Yeah, because their perspective drawing in the background is what fools you.
And then this one...
That's a space warper, actually. When you spin it, it gets your brain confused. And then when you look at something else, like here, I have an octopus. And when you...
Can we show it to the camera there?
And when you spin the space warper, and you look at it for about 15 seconds and take your eyes off of it, when you look at the octopus, it looks like it's come alive, like it moves around and stuff. It's really neat.
What about this one? This is a cube, is it?
Yeah, it's a conundrum cube, actually. I did a graph on that one, too. I wanted to see if... Oh, sorry. I wanted to see if people could see a cube coming out or a cube coming in, like going in or out. And once again, the adults and children see pretty much the exact same thing. But if there were more adults and I asked more children, the outcome would have probably been different. So, but there wasn't enough teachers to actually ask more. So, because our school isn't very big. Well, it is, but there's not many teachers in it. So.
Now, were you supplied various topics to choose from, or did you say, no, I've got something in my head that I want to talk?
Actually, we got to pick whatever we wanted to do it on. We didn't get to, we could have chose from stuff, but we didn't. Like, most of my classmates chose whatever they wanted. So I chose what I wanted to. Because my mom, she bought this actually, and when I seen it, I said, I know what I'm going to do my science fair project on. And she goes, what? And I go, optical illusion. And she goes, that's a good idea.
So do you think you'll be a scientist in the future?
No, I don't think so.
What do you want to be?
I want to be a physiotherapist.
All right, but that still involves science.
Yeah.
Well done. And, well, have you been judged yet?
Yeah, I have actually. I got third.
Oh, good for you. Oh, gee. All right. Well, good luck for the rest of the day.
Thank you. Bye.
We have a young man from the Belleville District Christian School. And what grade are you?
Grade 5.
And your name is Eric?
Friends.
All right. Now, you chose, does the amount of light affect egg production?
Yes, it does.
Now, why did you choose that? Do you live on a farm?
Yes, I do.
Can you space around a little bit so we can see your face?
Okay.
Okay, so what was your question was that, and what did you do to prove your hypothesis?
That when chickens have just daily light, and then I put a timer in with a treble light, and I put another 5 hours on, and now they lay about 8 to 9 to 10 eggs with 12 leghorn chickens. And before, when they're just on 10 hours of light, they gave 2 to 3 to 4 eggs, and you can see how much more they have jumped.
So your chickens produce brown eggs?
Yes.
What kind of chickens do you have?
We have leghorns and hybrid, I think. I'm not sure what it is, though.
Okay. So how long did it take to prove this?
14 days.
And you had to present it to the rest of the school?
Yes, I did.
Okay, so what are we, oh, you've already been judged too. And you've got second place.
Yeah.
Well done.
Thanks.
What did you tell the judge?
I explained what I did. I told, and they asked me what should I do next year. Like if I did this again, then I said I would maybe do more hours, like try 18 hours and some more hours and see what the difference would be.
How many chickens did you use?
12.
Ah, now do you have more than that, or your parents have more than that, but you just chose those and your parents allowed you to use those 12 chickens?
Yes. Yeah.
And how many eggs did they lay?
Pardon?
How many eggs did they lay when, according to the light?
The 12?
12?
Well, the 12 chickens, they laid 8 to 9 to 10 eggs a day from those 12 chickens.
And the light was how many hours?
15.
So it really does affect the way they lay their eggs.
Yes, it does.
So do you want to become a future scientist?
I want to be a farmer. I want to milk dairy cows. I got.
Okay, so well, it still entails science as well, especially in today's farming. So hopefully you will take up a lot of science in your courses in the future.
Yeah.
Okay, well done, and congratulations.
Thank you.
We have with us Eric Whitley, a grade 6 student from Trenton Christian School. And you chose the topic what?
Oxidation.
And what did you use?
I used certain objects like nails, pennies, steel wool, and I also used nails and other objects with platings and finishings on them to see if they would really prevent rusting. And I've got them in these jars here. And the ones that have platings and finishings are the ones in the cups.
When you say platings and finishings, what kind?
So like aluminum, brass plating, galvanized, things that would prevent rusting.
And I see you got photographs of, Trenton Skyway Bridge. Okay.
Yeah, we got pictures from that, and it shows that it is rusting quite a bit. And there's also other things along the waterfront that were rusting as well.
Okay, what causes, why would the bridge or the things on the bridge rust then?
Well, they didn't, I think it was because they didn't paint it at the time of construction, and that was a mistake. They should have, and they should have been if they didn't paint it, then the rust could come about really easy.
And I see you have a picture of a pickup truck as well.
Yeah, that was from Al Weiss's parking lot downtown, and it must have been in some sort of crash or something. The rust.
It shows the rust and the oxidation. Okay, so you were presenting a problem and the hypothesis.
My problem was, how does air, salt, and moisture affect different types of metals? And at first I thought the jars that had open lids, because I had some with closed lids and some with open lids, they would rust quicker because the air would be able to get at it. And I also had some of the water was salt to represent seawater, because I wanted to see how that would affect it. And I thought it would go a lot quicker too, but that wasn't the case. It was all the same, even the ones with the open lids and the closed lids. They all rusted about the same amount.
Oh, which surprises me.
And
what did you have to go through you chose all these different objects, and you did took pictures of various places as well, but various objects, and what rusted the fastest, what was slower, what objects?
Well, actually, they all rusted about the same amount.
Even the pennies?
Well, not the pennies. The pennies, they haven't rusted even now. They still haven't rusted at all. It's because they're copper, and copper doesn't rust as fast. But all the other objects, they rusted, and even some of the painted ones. Even some of the painted ones rusting. And there was only one plated metal that rusted. It was the brass plated. It rusted because there was a crack in the plating, and the rust could form in the crack, and it started rusting the whole thing.
So that's what people have to take into consideration when they're building something or repairing something, that there's no cracks in any of this.
Yeah, there's also a corporation called VTech, and they monitor corrosion on bridges and other objects. So, and they have this machine, and it beeps and sends a signal when there's the first signs of corrosion, so they can help bridges.
So you went around to different places as well to find out more information?
On the internet, I went on the internet and found lots of information there, and I found lots of information in books, and I went around, and I even called people that were in charge of the repairing of the waterfront, and they said that they might have some plans of repairing, but they aren't sure.
Very good. Are you going to become a politician?
I don't know.
What about a scientist?
It's too early to say, I think.
Have you thought about your future in any way, what you might want to become?
Well, I'm thinking about being an engineer. An engineer, I'd like to be that because I love designing things and stuff like that. And I'd like constructing things as well.
Well done. It took a lot of work and a lot of forethought. So I wish you the best of luck in your future, and I hope you do become an engineer or a scientist.
Thank you.
Okay, thank you very much, Eric. Okay, got 2 grade 6 students from Madoc Public School, and your name?
Samantha Butts. Madeline Maltby.
And how old are you?
I'm 11. 12.
And who's your teacher?
Mr. Armstrong.
Okay. He's the one that got you to do the science project?
No, Miss Hornick and Miss Tracy.
So I see you've got something that says pump it up. Always think of exercise program for that. What's it all about?
It's a centrifugal hand pump where you pump water up a tube.
So why did you choose this project?
Well, Sam's dad, he is sort of a engineer, and he has his own company, so he gave us some reference about it. So.
Oh, and so you went along with this?
Yes.
So, okay, can you explain what this is about?
Okay. Well, this is a centrifugal hand pump, and it works by, we spin the wheel here, and it makes the belt rotate, which makes the shaft move, and it's attached to an impeller, which goes around creating a centrifugal force, and it pumps the water up this tube. I'll demonstrate. And we measure how high it goes.
So it all depends on your strength then to get up. The faster you go, the higher it goes.
And we have different variables here. We have a small wheel and a large wheel. And we have a curved blade and a straight blade, and we're seeing which ones work better together. And we found that the large wheel and the straight blade work better because this was supposed to work better, but it didn't because we're supposed to have it's supposed to look like that, but it doesn't. It's not designed like that, so it doesn't work right. So the straight blade works better. And do you want to have one?
Now, where can you apply this?
If you had like a flood in your basement, you could stick the
Actually, I've got one right now, flood. Yeah.
you could get a bigger version of this, and you could stick the tube outside of the wall and then pump the water outside.
Ah, where else do you think you could use this?
Not quite sure.
Not a paddle boat or anything like that. Washing machine.
Maybe something to do with pumping water out of a well if you needed to or something.
Ah, interesting. Do you think you'll become a scientist in the future?
I don't know.
What are some things you would like to do in the future?
I would like to become a veterinarian.
Oh, good. Well, you need scientists for that. What about you?
I don't know yet. I'm not quite
And not even an inkling?
Pardon?
Not even a thought? No. Well, have you been judged yet? Or,
Yep.
Yeah. Did you get anything?
We came first.
Good for you. Wow, you really impressed those judges.
Yeah.
So what kind of questions would they ask?
Well, what it was and how it works and stuff like that.
Yeah. And
How we could apply it to the real world, the application and stuff like that.
which was the pump in the basement.
Yeah.
Very good. Well done. And congratulations. And I hope you do well in the future and continue with the sciences. Okay. We have 2 grade 8 students from Bayside Public School. And your name?
Thaddeus Kwan,
And your age?
13.
Every time I ask somebody their age, they have to think about it. Your name?
It's Derek Suchulam.
And your age?
I'm 13 years old.
And both of you chose to work together on oil spill simulations. Oh my goodness, my words are getting all tired. So what made you choose this?
Well, originally we were going to do tornadoes, but it's almost unpredictable. So we chose to do oil spill simulations because once it's happened, you can predict where it's going to end up.
So, and you obviously thought along the same lines.
Yeah, well, in last fall there was an oil spill in BC, so I kind of got my idea from that.
So I see yours is computer generated. You haven't got any other demonstrations other than what you put on the computer?
No.
So what did you do to, what is your focus then?
Well, the concept of this program is to create a simulation of 1 to 5 oil spills. The program was made to demonstrate the way in which wind, current, amount of oil in the tanker, the size of the hole in the tanker, and also the size and shape of the land will affect the distribution of oil in the environment.
Oh, and you did this in grade 8?
Yeah. So actually I skipped a grade, so I'm a year younger than he is.
Oh, I see. One of these brains. Okay. You're going to be a scientist.
Well, perhaps.
Okay, so how did you go about doing what you wanted to do? Describing.
Okay, well, first we had to make a grid, which is 70 by 50, and then we had to make the wind and current.
And a grid is a chart.
Yeah. And the wind and current, we could make it go 360 degrees, like the direction. And then we also had to make the oil increase in concentration outside the ship and decrease in concentration inside the ship. And we also had to make a mouse program so we could input land using a mouse. And that's about it.
You did this in grade 8?
Yeah.
I am impressed. So then the next step was to put it on the computer?
Yep, we basically inputted the mouse program into the other program, and what we got was this program.
And anybody can use it?
Pretty much anybody, as long as you follow the instructions.
Now, the oil spill that you did, or you just concentrated on one oil spill? No, you did. You took several, didn't you?
Well, you can have one oil spill, or you can have 2 up to 5 at the same time.
So it doesn't depend on the size of the ship or anything like that, or how much oil, or...
Well, you can enter the amount of oil inside of the ship, but not the size of the ship.
Okay. So, anyway, your observation.
Well, in our observations, we found out that we had 3 limitations.
Okay, assumptions. Go on.
Assumptions. So the first one is that the wind and the current can only spread oil to 2 boxes because we didn't know enough math to spread it to 3 to make it more realistic. But it's good enough. So that's why our diagram there is only 2 boxes.
I hope you go on to was it the Nationals?
Yep.
Yeah. And it's very impressive. I think you'll do well. Congratulations.
Thank you.
Okay, we have Arjun, who's a grade 11 student from Nicholson, and we've actually interviewed him before because you went to Canada wide.
Yeah, that's right.
Where was it last year?
I was in London.
And did you enjoy it?
It was fun because it was at Western Ontario and it was really interesting.
Is that where you want to go eventually?
No, I'd rather go to Waterloo, but you know, if that happens.
Okay, and you chose RoboVision.
Yeah, RoboVision. It's basically putting hardware and software together, making software run a robot. And I designed the robot myself, I designed the software for myself, and everything was made from scratch, so that's what makes it interesting.
Okay, where's the robot again?
This here is the robot. It's completely wireless, as you can see. No connection to the computer. However, the computer does control it. So it has a certain number of commands, like go, rotate, and it has a certain number of angles of rotation, and it's used to be able to drive things, kind of like a radio-controlled car, but a lot more complicated. Now, it also has cameras, and the cameras can also rotate, as you can see. And what they're used for is robotic vision. So I developed a software application that actually controls this robot automatically. So a user could define a course, such as a start point and an end point, and a couple control points, so I could drive through. And the robot will go from here to there, to there, to there, through there, all the while detecting obstacles along the way, using these 2 cameras here. Now, I can't give a practical demonstration because I have a lot of video interference because there's cell phones and other radio frequencies, so that kind of messes it up. But everything will drive aside from the video being transmitted because of interference. And the computer controls all the processes of the robot.
Okay, now you made this from scratch. Where'd you get the materials?
Well, the wood, you know, it's wood. This I bought at a hardware store, which is the microcontroller, and the bus that you connect it to. These other materials, I wired them myself, and I got them from I got the parts from different stores in Napanee and Kingston. And these cameras I had to order off the internet because you can't really get wireless cameras around here. The servos, I pulled them right out of a radio control airplane, and I wired them to this. So everything's pulled from different parts, and I made it into a big robot.
So a lot of work and a lot of searching.
That's right. There was a lot of searching because these aren't the kind of things you can find anywhere. Even on the internet, it's difficult to find, so I had to order it off the internet.
Now, you knew specifically what you wanted. Did you have to think about it, or did you have to read up on it?
I didn't know specifically at first. I sort of learned as I went along. You know, I made one board, then I learned a little about the next one, and eventually I knew exactly what I wanted, and I put it all together. But along the way, that was the hard thing, because I had a lot of stuff to think about.
Like, how long from the beginning of your thought to completion did all this take? Because like I said, it takes a lot of work to search for all these components and then to hook it up so it's compatible with your computer, and then to get all this done as well. But I mean, to even think of the parts that you want.
Well, I actually thought of the idea early in September, but I never actually got around to starting creating anything until maybe mid-December. And then around December, I started ordering all the parts I needed, got rid of some parts I ordered because I didn't think they were useful, and back and forth like that until I finally got what I needed and created everything. It took about 3 full months to make the hardware, and then maybe another month to do the software and hardware together. And both of them working together is an intense process, but eventually you get it going.
Are you one of these creative people that once you get a bug and you start working on it, you go till 2, 3 in the morning and you just concentrate and just can't keep it out of your mind?
Kind of. I don't go till 2, 3 in the morning because I like my sleep. But yeah, if I find a problem, I'll work on it until I fix it. But thankfully, most of it got fixed that same night, so it was pretty good.
So where are you going to go from here? Like when you finish school, where do you think you'll be going?
University, hopefully in Waterloo, but
to take what?
Computer engineering. Well, like I said, hopefully, because it's really difficult to get in, but hopefully computer engineering or Waterloo, yeah.
I think you've done a lot for a lead up to that. I think you've done really well. Now, have you been judged yet?
I have been judged, and I got a first.
Of course. Why did we even ask you? Of course you would.
Actually, there's no guarantee, but,
Okay, so where's the Nationals going to be held this year?
I think they're in Kingston.
Oh, so you don't have to go too far.
If I win, I probably wouldn't have to go very far.
So you still have to be judged to see whether you go on then.
Right, I still have to be judged 2 or 3 more times until I know if I'm going to go on. But, it's always hanging, so you never know.
Now, besides all the computer fix-ups and all this demonstration, what did you have to write up?
This whole board is written with material and theories about how this robot works. I mean, I'm sure it looks simple, but all this stuff is what's gone into building this robot. There's lots of diagrams, lots of math that goes into it, lots of theories, ways of working, and a hell of a lot of hours that go into putting all this stuff together. So.
And I see you've actually got a purpose up there while you're doing this.
Yeah, actually it wasn't much of a purpose. It's just to create an intelligent robot that follows the 3D path.
So you've done robots before, haven't you?
No, actually this is my first year for hardware, and that's why I'm doing it. I didn't want to just do hardware, I didn't want to just do software, so I put them both together, and I learned hardware in the process while putting software together with it.
Well done, and congratulations, and I hope you go on, and I hope you do well in the future.
Thank you.
We need more people like you.
Thank you.
Sargent, by the way, don't forget his name. We have Brennan Eberwein from a grade 6 public school student from Massasauga, Resnisville.
Yep.
And what project did you choose?
I chose a memory project, and it's basically, it's most basically Simon Says. The balls flash, and the balls flash in a correct sequence, and you have to follow that correct sequence by clicking on it.
Okay, what are you trying to prove then?
I'm trying to see if by using your eyes and ears, which is visual and auditory, if you can remember more than by using just your eyes.
Now, did you test this on a number of students?
I tested it on 8 people, and my test result was that you could get a better score using just your eyes than using your eyes and your ears.
Really? Okay, because some people do better by hearing, some people do by looking, some people by looking, hearing, and talking about it.
Yeah. Yep.
So you said by seeing is the better result.
Yeah.
So, okay, how did you go about it? How did you go about it besides testing on, you used the computer, did you?
Yeah.
And you had the simulation of a ball going to...
I had 3 balls, red, green, and blue. And what happens was they would flash, and if you use your eyes and your ears, you could hear it say green or red or blue.
Oh, so they had to shout that out.
Yeah.
And then you wrote down the result?
Yeah, I wrote down the results.
Okay, who made the program on the computer then?
I did.
Very good. Okay. Now you wrote. Okay. Question: what was the question?
Is it possible to remember more using your eyes as well as your ears? In other words, are 2 senses better than 1?
And you found the one sense better than the other.
Yeah.
Okay, and that was so you had to go through a hypothesis. You had to write down the materials, and the materials was what?
A computer, a program called Calgary True Space, Bryce 2, and Blitz Basic, and DirectX 7. And I use Corel Suite 8 for the graphs and the charts.
Okay. And then you also had to write up the graphs by hand, not by the computer.
Yep.
So how long did it take you to put all this together?
75 hours, approximately.
Oh, you wrote all this down.
Yeah.
You put a lot of work into it.
Yeah.
Yes. So are you hoping to go on to something in science in the future, like what? Anything. Is it?
Yeah.
Yeah. So it's not just computers, or would you prefer computers?
For computers.
Like engineering?
Programming. Yep.
Oh, well done. So you've got your future mapped out for you already.
Yeah.
And I see you've won. You've been judged and you won first prize. Now, more judges have to go around to determine whether you're going on to the nationals.
Yep.
And you're hoping to get there. Is this your first year at the science fair?
Yep.
Well done. Wow. I hope you get there. So from what I hear, it's quite the experience.
Okay.
Best of luck in the future, and I hope you get to the nationals.
Thank you.
Thank you. Okay, we have Jeremy Gibbs, a grade 8 student from Harry J. Clark, and very impressive. You've won first prize.
Thank you.
Are you going on to the nationals, do you know?
No, I don't know yet.
So you still got more judging to go.
Yes.
So what did you choose?
I chose to do a water quality study for the Bay of Quinte.
Oh, that's what we need. Yes.
Yeah.
And?
Well, it is what I did is since the Bay of Quinte became a problem area because it was so dirty in 1975, and even after action was taken to clean it up, it was still dirty, so they created the Bay of Quinte Remedial Action Plan. So I decided to see if it had been working, and I tested one of the tributaries running into it because I thought that if the tributary was clean, then it would help the water flowing into the Bay of Quinte become cleaner.
Okay, which tributary?
Bell Creek.
Where's that located?
Well, I have a map here. It's located right beside. It flows down from up past the 401, down past through the Stanley Park residential area, down through Oak Ridge, past Farley into the Bay of Quinte.
Okay, and what did you find?
That the water was exceptionally clean, although it did have highs and lows. But the highs and lows were pretty much buffered out by the swamp and the limestone and everything that it ran through.
So really, we should be keeping all our swampland and not filling it in with concrete houses.
Yeah, our wetlands should be kept.
So was that your final conclusion then, that we should keep the wetlands, or that just those two, you were concentrating on the water flow?
Yes, we should keep the wetlands, and we should try and make sure that all of our streams and creeks running into the Bay of Quinte are like that.
So how long have you been working on this project?
Well, I started in about last September to November.
And then it froze over and you couldn't do much. So you haven't done anything recently, I suppose?
Well, I did my testing then, and I've been doing all the conclusions and follow-up since then. Yeah.
Oh, very good. So we do need this on a regular basis, and it's good that somebody takes an interest in this.
Yes.
Yeah. So you're finding the bay is slowly cleaning up?
Yeah, well, the water running into the bay is pretty clean. It's definitely cleaner than the Moira River, so yeah, it should be cleaning up.
So we just need to get rid of the Moira River then?
Yeah.
Yeah, well done then. So you hopefully you might be able to present this at the Nationals. Now, have you presented science projects before?
Yes, last year.
What did you do last year?
I tested batteries. I created my own battery and tested it to see if we had improved on them or not.
And you have never been on to nationals or anything? No. So hopefully you'll get an idea and go on to that. Now, would you like to, in your future plans, carry on in school and do something along these lines?
Yeah.
So I can see university or college, because college also covers this whole thing. So you've got a number of choices, and we do need more people like you.
Yeah, thank you.
Good luck then, and congratulations on first prize.
Thank you.
Thank you. Okay, we have Chris Spencer, who's a grade 8 student at Heritage. Oh, no, sorry. I've been saying this all day now, yeah. No, he's one of the teachers at Harry J. Clark, and he's one of the big organizers of today at the mall of the science fair. And you've done this for how many years now?
Well, this is probably my 22nd year.
You've pretty well been, well, no, it's been like 40 some odd years, I guess it's been going, but you've been in at least over half then.
It appears that way, yeah. Yes, I've been involved with it right from the beginning of my teaching career, and my involvement is increased as I've gone along. Starting out just as a judge, and now I've got several other roles as well.
And the volunteers from the schools, college, from industry and other private citizens, it's really expanded, and a lot of them come back year after year after year.
The group of volunteers that help out with the fair is a very dedicated bunch, and yes, with 41 years of history, we built up a really large group of people who stay and come back year after year, so we can call on people from all walks of life to help us out, and they all see it as a very worthwhile endeavor.
You know, I walked into the mall today and I saw the president of Loyalist College, Doug Old. He was judging, but I thought, gee, that looks like Doug Old. And I walked by and I turned back and I thought, that looks like Doug Old. And it was. I thought, he's here judging today as well.
Well, it's a wonderful place to meet really interested students, people who are interested in all kinds of things, and to see some first-rate thinking. These kids, they start with a project. The real benefit isn't that they do a science project, it's that they've taken a major project and carried the thinking through from a basic question through research to a conclusion, and they've expressed themselves clearly. So it has importance for all walks of life.
Oh, definitely. It gives them a lot of confidence, having to stand up in front of people and having to explain their ideas to judges. I mean, that's terrifying in itself. I know some of them feel confident, naturally feel that way, but there's others that really struggle with it and have done well. I've spoke with a few students today, and I was amazed at their presentation and how well they could speak. And even though they were a little bit nervous.
Well, they're told that they should rehearse their presentation before they come. Many of them, of course, have already presented before their peers and in their classrooms and at the school level. So by the time they get here, they should be fairly polished.
But, you know, it's still not easy. So, I mean, people think, oh, they're my friends, I can do that. But sometimes that's the hardest thing to do, to present in front of co-workers or friends, because you think, oh, you're being judged the most, whereas in front of strangers you think, oh, well, it doesn't matter.
That's certainly true, but I think the students that get here are ones that have the extra communication ability, because it's one of the major parts of doing well at a fair.
Now, a lot of these students are planning their future around science. Others, they're not sure what they want to do, but it sure is going to help in whatever they do in the future. Just the experience of today and of past years. And if they do go on to nationals, that's really something.
Well, the simplest way to put it, it looks really good on your resume to say that you've competed in a regional science fair. It looks even better if you've been to a Canada-wide.
Now, Canada-wide this year is in Kingston?
Yes, Kingston, just down the road, so that makes it easy for your viewers to have a look at what some really extraordinary projects are. The projects we have here compete very well at Canada-wide, so they will see some of our best. They'll see a whole fair of what's equal to our best. And yeah, it's available. It's the first week in May, before the long weekend. That's when the Canada-wide is, and that's Saturday. I believe it's around the 12th or 13th. There's public viewing in the morning, and it's an excellent opportunity for people to see some first-rate work.
Now, we're sorry that we couldn't get there was a lot of projects we missed today that we would like to have gone on, but we had some technical difficulties. We were unable to get them. But oh my goodness, and everybody wanted to be on the show. Look what I did, or whatever, you know. And we wanted to do it, but we can't cover everybody's project, which is very disappointing.
No, it is disappointing. It's disappointing in the fact that another way, in the sense that especially in the intermediate division, the competition is really, really hot. We could have had 6 different projects go to Canada-wide, and I know we'll only be able to send 2 or 3 students. And it's really unfortunate for those who don't go. Other than that, they do get a really, the idea here is that they get a really thorough hearing, a very sympathetic ear, and that people understand what they've done. So that even if they don't go, they know what they could do to improve for future.
So we especially want to thank the volunteers today. Jim, the head of the judges.
Oh, Jim Galway, Chief Judge?
Yes. He's done an excellent job every year. He keeps coming back, the poor soul.
Well, this is Jim's last year, I believe, yes. Yeah, he will be passing on the torch next year, I believe, to another Chief Judge.
Should have nabbed him too. But anyway, we're going to thank all the volunteers today. We want to thank our and of course you've got students. Actually, we'd like them to come in today. They've been following us all day long, and they're your special students from Harry J. Clark. And who have we got?
Andrew Holt.
Yes, you poor soul. You got suckered into this, didn't you, Anne?
Aaron Sargentson.
Yes.
And Mitch Thibodeau.
And they've been excellent. They've been holding off the public from crossing in front of the cameras today. And they've been walking around on concrete floor, and you could see sometimes their shoulders were sagging, and then they come up and come with us, and they always had a smile on their face. So I want to thank you 3 for coming with us today. Thank you, Chris, Spencer, again, for a really great opportunity to see what potential we've got in our community.
Thank you very much for allowing us to showcase it. It's really important, I think, that the community sees that students in this area are of the highest caliber anywhere, and that it's a really good opportunity to see just what they can do.
Okay, we've been at the Quinte Mall for
the Quinte Regional Science and Technology Fair, the 41st edition.
Okay, thanks for watching. I'm Leslie Ingram.
Think back to your high school years. Were you laying the groundwork for the career you now have? Probably not. But some students spent this weekend doing just that. We want to introduce you to some of these up-and-coming young scientists. They were competing in last week's Canada-wide science fair. And as you'll see, these projects are not your run-of-the-mill volcano experiment. The results some of the students got could have huge implications for the world of science, not to mention for themselves.
There were over 450 students from across the country at the Canada-wide Science Fair held in Kingston, Ontario. This is a place where scholarships, awards, and getting a good name for yourself early are all hot commodities up for grabs.
Well, when I was in grade 4, I used to do the science fair with the little electromagnets and the volcanoes. And eventually I evolved to computer projects and robotics, and I decided that's where I'm going to stay for the next couple of years.
It seems he made the right decision. He did very well with the robot he created for this year's science fair.
I used multiple different types of technology, such as wireless video, wireless data, software, and hardware. The video comes from these 2 cameras, and they're used as the vision for the robot. The video data is sent back through the computer, and the data is analyzed, such as like their 2 eyes, like the human eyes. And they focus on targets, images, obstacles, whatever. And the cameras are used to actually detect obstacles in front of it. Certain applications of it would be to explore territory, such as Mars or underwater, where you can't really take a human being. And there you could use this to intelligently explore the area around it. Also for law enforcement, chasing criminals in cars, it would be very useful, where it can automatically follow a target.
Now this is a device that might even interest U.S. President George W. Bush. Shauna Gammon wanted to produce environmentally safe energy.
My project is a chemical thermocell. Now basically this is a system for converting low-grade heat directly into electricity. Low-grade heat is just any day heat, like from a flame from hot water. And in my project, I used this type of system. I tested over 20 different solutions with 2 carbon electrodes in them. And when there's a temperature differential between these electrodes, it produces electricity. Now this type of system has absolutely no kind of environmental repercussions or any such things like that. It's completely self-sustained, it doesn't use up any of the chemicals, and it basically produces power just out of a temperature difference, nothing more.
Other students settled for nothing less than as far as the eye can, or should we say, can barely see.
I've been passionate about astronomy for a long time. Since I was in grade school, I've been staring at the night sky.
For his project, Francis Bulva looked into Wolf-Rayet stars. They're hot, massive, luminous stars, 3 times the size of our own sun.
Well, my project Galactic Champagne helped me understand better the origins of Wolf-Rayet stars. These are extremely massive stars in our galaxy, and they tend to form bubble-like shape of gas around them. We see here the gas expanding through space, and sometimes it creates a bubble of gas because of the shock wave it creates with the direct interaction of the interstellar medium and dust. And by studying the structure of these bubbles, I was able to understand better the origins of the Wolf-Rayet stars. And this is extremely important to do because it has a great impact on the dynamic and evolution of stars.
Then from heavenly bodies in space to our own.
And the brain has been something which always fascinated me. I've done brain tumor research as well.
For Neha Datta, this fascination has paid off. Before even arriving here, she got a $90,000 grant to further her studies.
Basically what my project has been able to do is identify a new gene and link this gene to dyslexia. Now, I've been able to show that this gene controls something known as the first regressive event. Now, all humans go through this event during the 2nd trimester of pregnancy. And what it does is it controls something called neural pruning, where up to 40% of the neurons are killed off. Now, in dyslexic individuals, this pruning occurs abnormally, and the mechanism controlling it is functioning abnormally, such that dyslexics have a larger right hemisphere than the left. Now, through various biomedical and biotechnological techniques, I was able to determine that this is one of the factors contributing to the first regressive event, and that this gene is one of the factors in causing developmental dyslexia.
With most of these bright young individuals looking for careers in science, this Canada-wide science fair, with its awards and scholarships, is a great place for them to start.
When we come